Let us start calculating first of all the values for input port 1 by keeping the terminals 2 as open circuited. And first of all we are going to calculate the open circuited impedance calculated at port 1. After that we will be doing the same process for the short circuited impedance by keeping the terminals of the that is output port or port 2 as the short circuited by any kind of the conducting wire. And over here this is a milliammeter which is connected in series, and we have to then calculate the voltage through the voltmeter or the multimeter. So after that we will be then calculating the characteristic impedance at input port, which is given by the formula square root of multiplication of the open circuited impedance which is calculated at input port multiplied by the short circuited impedance calculated at the that is input port again. Let us start the practical. So this is the power supply. Over here connections are being made, and if you can see, this is a T type of the network in which we are having both of the series arm are same, and this is one of the shunt arm. Let us turn on this power supply. From DC power supply we are giving nearly 4.1 volt, and this is my positive terminal, and you can see that this positive terminal over here that is being connected here, and this is how the connections are coming. This is and from here you can see this is my red terminal of voltmeter also coming in the same line because it is vertically shorted, and over here the third wire is belonging to that particular ammeter. Clear? Negative terminal of the ammeter, from here it is going, let us see, this is, and it is going to that particular input of that you can see first series resistance. Clear? In the same line. So this is how it is connected. Clear? Now, as we are giving this particular voltage from the DC power supply, we have to just only note down what is the value being recorded by the voltmeter as well as that kind of the milliammeter. If you can see this particular division, I have calculated on 30 volts, so I will be taking the readings from the upper scale which is on the top. Okay, so my deflection needle which is being shown with the red color line needle, that is being going on 5, that means it is reading 5 volt. And similarly at that time the current is being considered over here. First of all you have to consider the divisions. It is 1, then 2, 3, 4, 5, it means it is 1 milliampere. Okay, so based on that we have to note down that particular reading over here. That is this is my reading, that is 5 volt 1 milliampere. Okay, and now with the same applied voltage I will be now calculating for the short circuited values. For shorting the second port 2, I will be connecting one terminal over here, okay, for that particular conducting wire, and the another terminal I will be connecting over here with the shunt arm. See, now with the same applied voltage, let us see what is my voltage. Voltage remains at the 5 volt only, but there is now slightly change. Earlier it was 1 milliampere, now the current it is showing to be 2 milliampere. Okay, so this is my 2 milliampere. So this is my first reading. I have taken 2 readings, so you can understand it properly. Let us now change that particular voltage by moving this particular knob slightly. Let us consider nearly 6.6 volt. Okay, so let us now see the current and the voltage. Now, but for that, okay, again it is a short circuited one. Okay, so let me first of all note down the readings for the short circuited. Over here if you can see, it is reading nearly over here it is considered as 6, then it is 7, and if you see it's going nearly at 8. So here I have just written it is 8 volt. Let us see what is the reading over here. It's 1, then 2, 3, 3.5. So it means it is 3.5 milliampere. Clear? Now in order to have the open circuited, I will be removing this short circuit connection directly from the port 2. Now with the same applied voltage, let us consider. Now with the same applied voltage, you can see that it is reading nearly 8 volt on the voltmeter. And now we are calculating for the open circuited impedance. And over here the current it is now measuring, it's being considered nearly, that is 2 milliampere. Okay. So here we have just note down, though this is my second reading. After that, what you have to do, that in order to calculate the impedance values, you have to take the division of the voltage and the current, like it is 5 by 1 into 10 raised to power minus 3. Similarly over here, you will be calculating in terms of 8 by 2 into 10 raised to power minus 3 and calculating those values. Similarly, you have to repeat the process for the short circuit impedance, and after that you have to calculate over here, complete the table by calculating the values for both the readings in terms of that what is the value for the this characteristic impedance measured at port 1. In a similar way, we have to then that is calculate it for the observation table, okay, at that is calculating at the output port, in which we will be now calculating the open circuited impedance as well as the short circuited impedance at the output terminal by keeping the input terminal as open or short circuited.